and essentially what we may do is make the recording available to everybody after the session. So without further ado, I'll move into the detail of the session. So, always good to start off with the contextualization. So at a sort of highest level, we've got the, sustainable development, and then within sustainable development, we have the goals after 2015, and many of those goals still aligned to circular economy. Circular economy as a concept came out of various schools of thought, particularly around resource efficiency, resource productivity, and we've really, seen the whole usage of the terminology particularly grow over the last 10 years. This is taken from a Google tool that monitors keyword searches, so we can sort of see the ongoing growth of use of the terminology. And of course, when we look at the product side of this, we've got the eponymous sort of butterfly diagram that talks about products for the biological system and then products for the technical system that built on original work by McDonough and Braungart. But in reality, we know that many products are mixed materials, often including both bio and technical products, if you like. So here's, for example, Star socks. These are socks that are made using nylon for fishing gear, with organic cotton and elastomer. So essentially, it's a movement in the right direction, but by mixing those materials effectively, we're still designing for landfill, unless we start to build in separation. We've got many models and checklists emerging, often that are more to do with the technical system, or products for the technical system rather than for the biological system. And effectively, when we're thinking about particularly design and development, it's not just thinking about the development of new products, it's about the redesign of existing products and how we potentially can redesign for repairability, remanufacturability, etc., etc. So thinking sort of big picture and small picture, particularly some of the work that Connie Backer and others have done is look more proactive thinking around what a circular economy might look like. And of course, that's a theoretical state at the moment. So if we were to have a circular economy, what might products, services and systems look like within that, both from a technical and biological and hybrid perspective? So there's a sort of top-down idea of what products might look like, but then we've got a more pragmatic question, in terms of today almost, is circular design just a subset of eco-design? And, some of the issues we need to think about in terms of circular design by itself, if we're not looking at energy and water, may take us down the wrong path, and we need to look at sort of all the issues to do with trade-offs. Many definitions of circularity, circular economy out there. Within ISO now, there's an approach, various strategies in development to develop some agreement over terminology and definitions. So within ISO, there is a definition emerging around an economic system that systematically maintains a circular flow of resources by regenerating, retaining, and adding to their value whilst contributing to sustainable development. So there's this sort of regeneration, retention, adding value here, setting within the context of sustainable development. The original circular economy standard was the BS 8001, which was very general. I had some, involvement in the team in developing this, and this looked both from an organizational perspective down to a sort of product perspective, but mainly at the organizational level, where a lot of activity still focuses. What we had in the back end of the 2010s was the agreement by ISO to move forward on a technical committee to take forward work on circular economy. And this has led to a series of standards that are in development at the moment. And of particular importance are the 59004 on terminology, principles for implementation. But we also have standards in development around business models and value networks and measuring and assessing circularity, as well as a couple of more informational technical reports. But also from a product point of view, the 59040 on product circularity data sheets. So this is more explicitly focused on product aspects, where particularly the first two standards are much more focused at a sort of organizational business unit level. And the measurement standard, whilst addressing some of those product issues, is still a little more focused on the organizational level. What of course we also had for is, as a result of the first Circular Economy Action Plan of the European Commission, the Commission briefed SEN, the European Standardization Body, to develop a series of standards around materials efficiency, which have now been published in 2019 and 2020. Whilst, in a sense, they're named materials efficiency standards, a lot of these really look at, aspects of circularity, remanufacturing, reuse, recycling, etc. But with these material efficiency standards, they were initially focused, or they were focused on energy-related products, so related to the original scope of the Eco-Design Directive. But what we're seeing is more and more activity, particularly within SEN and SENELECT, around new standards emerging. We've got the circular design standard that Solange is leading and heavily involved in. We've got the circular and recyclability of fishing gear, which again is looking at circular design there, and a series of other committees that are looking at circularity and a number of them at more of a product level. So we've got circularity, standards emerging around textiles and furniture, construction products. So we're starting to see, a focus not just on the organizational business unit level, but also at a product level as well. And I just thought I'd sort of, before we go back into circular design, it'd be useful just to review the emergence of the whole sort of product issue. So we originally had this Designing for the Real World that was produced or published in the 1960s by Victor Papanak, who started to look at sustainability issues and products. And then in the 1990s, we saw the evolution of terms like eco-design, design for environment, as a sort of product-based approach to address sustainability or environmental issues more specifically than broader sustainability issues. We then had in the early 2000s, the publication of the Cradle to Cradle book that really started to bring more of a circularity focus. And then that was relaunched later in the 2010s and gained a lot more interest. So we've seen, the emergence since the 1990s of approaches around looking at the environment, reducing the environmental impact of products, with different terminology, which effectively, which effectively means the same. So in an eco-design context, we've really got two core standards at the moment. We've got the IEC 62430-19 that focuses on environmentally conscious design at the level of product design and development. That was originally built on a standard for the electronics sector that had its brief broadened to all products and all types of organizations. And similarly, we had the ISO 14006, which is much more around how you implement eco-design into environmental management systems. And both of these now are out there and being used in their second iterations. And again, just going back to sort of brass tacks in a sense, internationally agreed by ISO and the IEC is a definition of eco-design. In IEC, it's termed environmentally conscious design, but we're effectively looking at a systematic approach that considers environmental aspects in design and development with the aim to reduce adverse environmental impacts across the life cycle of a product. And as is highlighted, the terms are less important than what's being talked about. But what we're also now seeing is the very specific Sen-Elect standard emerging that Solange is leading around circular design. And this is emerging because of circular economy becoming a growing part of ESG and broader sustainability focus of many organizations. And excuse me, the growing importance of thinking about the life cycle of products, and more specific thinking around optimizing products to narrow, slow, and close materials loops, but also to create new systems to close those loops as well. But within the standard also, it is addressing some of those trade-offs that we mentioned earlier. And within the standard, there's a lot of detail now starting to emerge about how companies can address these issues. And as I understand it, that the circular design standard is now also, from an original focus on energy-related products, starting to have a broader focus on all products and organizations. And Solange, I'm sure, will comment on this a little bit later. So before I pass across to Patrick, I'm just going to bring in a little bit of experience we've had from some depth research that we've done with 21 companies that are already addressing circularity in product circularity. So what we've recently done is this depth study amongst a series of companies who are already on that journey of circularity. So they're not thinking about it; they are already doing something from analysis that we've completed. Excuse me. And then what we've then done is to basically bring in some thinking in terms of maturity approaches, looking at whether they're early staged or more advanced in their approaches. And within this, we've looked at how companies are defining circularity, how they're measuring circularity, and some of the barriers. And I'll just share a couple of our findings to really sort of look at the sort of state of the art from companies sort of that are doing this. So once you get down to this, is that the understanding of how to implement circularity amongst even companies who are doing this is quite fragmented. The concept and IMO's definition of circular economy at a product level varies dependent on the type of product and the type of industry. In practice, at a product level, the most common focus areas at the moment in terms of addressing circularity at that product level is the use of recycled content and the use of bio-based materials, and also emerging thinking around design for disassembly. For those companies that we interviewed that were more at a basic or intermediate level, most of the thinking still appears to be around the use of recycled materials. For more advanced companies, focus is moving beyond recycling and recycled materials to thinking about broader, sustainability products, sustainability initiatives, and starting to bring in some of that hierarchy around circularity strategies. Actually, very interestingly, what we found, despite a number of the companies we interviewed, we know, having a lot of previous experience in eco-design, we found with the interviewees, and generally we went in at sort of director of sustainability level and through the teams, fewer people were using the term eco-design than we thought. And where eco-design was recognized as a practice in companies, product circularity was almost being considered separately to eco-design. It's interesting. I didn't move my slide there. So effectively, there is this sort of separation we're finding where circularity, both on a product level and an organizational level, is being looked at separately in a separate box, if you like, often not fully integrated. So in terms of measurement of product circularity, very few are using tools that are out there. What we found where companies are measuring it, they're often finding that a lot of the tools and techniques aren't fit for purpose in terms of what they need for the way they're operating. So a lot of internal tools and frameworks are being developed where they are, where benchmarking and measurement is happening. So what we found also is that some of the more advanced companies that are starting to think about more use phase related circularity, repair, refurbishment, remanufacturing, etc., are starting to develop, more sophisticated measurement metrics. But also from a company point of view, there's this perception of, an extensive number of frameworks and technique, tools and methodologies, but a lot of them not fitting the requirements for business. So just in closing this sort of background before moving across to Patrick, some of the barriers that we're seeing in terms of moving forward on product circularity are the costs associated with material substitution, maintaining functionality and product performance and aligning to customer expectations, and some of often perceptions associated with aesthetics of changes, particularly in materials. So I'll now pass across to Patrick.
Okay, great. Thank you, Martin. I hope you can hear me. I'll just continue, but as a brief background maybe. So I've been working on the circular economy topic for a number of years, but mainly on the aspects of international cooperation between countries and policies. And I've realized that in that discussion, there was often, or in many cases, to talk about we need to redesign the system, we need to redesign value chains, etc., etc. But I realized that I didn't actually know very much about design. That's when I decided to start some research with Martin and the Center for Sustainable Design to find out more about circular design. And so in this context then, so this is very much work in progress. I'm grateful for the opportunity to present some of this, and I'm keen to hear everyone's comments and feedback. So as you know, so within the circular economy, as it's defined, often it's said the circular economy is restorative and regenerative by design. And I've realized regenerative design and circular design actually are not the same thing. And so what I've tried to do in this slide here to pull these a little bit apart. And so on the one hand, and this is also draws on the Al MacArthur distinction between the technical nutrients, biological nutrients. And initially it seems circular design practices such as the reuse, recycling, repairability, refurbishment, etc., seems to apply more to the technical nutrients. And then if we look at regenerative design, where we have principles of built on living systems, self-healing properties, bio-based materials, and also this ambition of regenerative design to create a net positive impact on natural system, not just about reducing negative impacts, but creating basically a handprint, and I'll come to that a bit later. So, but obviously there's also, as Martin also alluded to before, there's hybrid materials that where these overlap. And it's, important to understand where these overlap and when it comes to also design practices and standards. Next slide, Martin. Great, thank you. So now, when it comes to regenerative design, it's not a necessarily new term. It's actually been around for quite a while. And these are maybe John Lyle with his publication from the 90s, Regenerative Design for Sustainable Development. It makes a link to circular economy in a way, but when he says regenerative design is replacing the linear system. There's also interesting the way it's been adopted. As we know, it's often in agriculture and in architecture and built environment. So the Royal Institute of British Architects come up with a regenerative design definition recently, which says, again, as I said, designs to regenerate rather than to deplete. And you might be familiar with this figure here on the right. And if you click through to the next one, so exactly, so we know very well about, and we have also methodologies to understand the bottom part, for example, life cycle assessment, the negative impacts of goods and services. But the question is, do we have the right methods to measure what the positive impact is of either be regenerative materials, products, processes, or the business models that build on this, and also how to measure, for example, if we extend it further, the aspect of regeneration for society, because it can also be linked to regeneration of societal processes, etc. So that's some questions I've been grappling with. I don't have the answers yet, but if we go to the next one. So, I mean, the reason why this is becoming important, because we can see increasing activity around this, publications about regenerative businesses. So there are a lot of guides which are coming out, but we also already see, for example, this is an example of the advertising, Tarzol Regenerative. So advocating for use in advertising for products. So the need to become a little bit more specific about the regenerative aspect and the positive impact it creates becomes important. Otherwise, it might just become an empty green claim that is being used. So it's really important to know what regenerative is in order to so that we don't lose the depth of this concept. And it is quite a very holistic and deep approach that we do need to move also beyond the less bad sustainability. Next one, Martin, please. So there's been some research that's on the way in this article, trying to pick apart actually the distinction between restoration and regeneration. That's also quite useful. And this article comes to the conclusion that currently restoration is a better defined concept than regeneration, and has some more practical application, whereas regeneration at the moment is often still a symbolic or evocative term. So that's something we need to work on. Next one. So then obviously the question is, so we need to start looking also at how do biological systems regenerate, and this is very much about the capacity of self-healing, restoring damaged or missing cells, etc. So if there's some principles here that could be interesting to explore further, how that works also within not just, for example, the example here of zebrafish, but how can these be applied, for example, to products and other wider systems that build on that. Next one. So there's some principles here that are also based on some work by some Chilean biologists on autopoiesis. So they're saying self-regeneration ability, it's not just in one place. It's not, it's a decentralized ability. So life is connected, or is dependent on the interconnected relationships of different parts of a cell. Life is holistic, emergent property, and each part is also self-regenerative system. So this is some of the fundamentals from biology and ecology. If we go next, then now, as you might know, or as I mentioned, so the application in agriculture, regenerative farming is a very frequently used term. And what we see there now is already this move towards some more standardization and also measurement. So this is a paper looking specifically at regenerative agriculture and agroforestry, which I won't go through the details here, but already looking at what are the specific criteria and what are some of the thresholds that we look at. And it's quite specific about the number of species in a certain area to create the biodiversity that's needed for enabling this regenerative capacity. Next one. Then, as I mentioned, so it's used in architecture as well, and it's a little bit an umbrella term that covers a number of things, as you can see here. But again, it's also not only about the materials and the environment, but it also links to people and community in these frameworks. Next one, please. So this now comes a little bit to the point I made about where we see maybe products or systems that merge, which have these characteristics of circular and regenerative. So these constructions, and there's quite a number of them that multi-story wooden buildings based on cross-laminated timber in a modular way, which is, I would say, more of a circular design feature. But then obviously the timber being grown through regenerative agroforestry practices brings in the regenerative part. So I think these new design innovations are quite interesting from different perspectives. Then if we go next, I have a few more examples of these. This is so this aspect of self-healing properties, self-healing materials. There's quite a lot of research going on in this space, and this applies. I mean, this applies to a number of materials, including polymers, metals, alloys, or composites, and yeah, inspired by natural processes. So these could be would be regenerative features of certain product categories. If we go next one, I think it's just more on that self-healing concrete. It's also often discussed. There's quite a lot published on this aspect. And next one. So this is going now into if we think about solar photovoltaics, you being a low carbon or potentially even zero carbon energy technology. So it's regenerative from that aspect, that it contributes to climate stabilization. But then the materials, the way they're sourced, and then the end of life issues of solar PV still has a negative impact. And through introducing circularity, obviously these are all technical materials, that impact can be reduced either through recycling the end of life panels, but also through new approaches. And this is some work by ITRI, an Institute Development Center based in Taiwan. So to have modular solar panels where the different components can be disassembled and reused. But all of this is still within the circular. What would it look like if we had regenerative solar panels? If we, Martin, go to the next slide, then we would move into something that's already being researched, biophotovoltaics, working more like microbial fuel cells, and they're being called also living solar cells. So these would have the ability of self-assembly and self-repair, but so at the moment, again, these have not been commercialized, and more standardization is required. But we might be able to see some merging of these biophotovoltaics in the future with other PV systems. And if you go to the next, similar maybe also for electronics like laptops. So we have circular design design approaches that are coming into the market. So the Lunar design by Dell, for example, in the mobile phone space, you could you have the Fairphone, and it's using some regenerative design solutions already, including bio-based materials. But then going on, what would be a regenerative computing system? If we go to the next one, there's some interesting work happening looking at fungal electronics. Again, still mainly in the research stage, but that could be also very interesting, as we've seen also fungi being used in other products and material developments. If we go to the next one, just conscious of time. So vegan leather, another new category that's emerging, and often these are from agricultural waste products or sustainable biomaterials, but not always. There's also hybrid materials where various types of plastics are combined, so certain material blends, and then, as also Martin mentioned again, are these then designed for basically circularity. So questions around that also need to be looked at. And then I think the final slide, now bring this back to the policy and the standards. So what we now have at the EU level is the new Eco-Design for Sustainable Products regulation that's been discussed for a number of years, and there's been public consultations. It will cover a whole range of end-use products, intermediate products, beyond the energy-using ones, and there's a number of design features that are being considered within this new policy. I think what it doesn't cover yet sufficiently is this aspect of regeneration, and the other questions related to maybe the blended materials, plus maybe if we expand just from the products and materials towards the business models that would be based on these aspects, as well as questions around how society will use these new types of products, and how the design will also shape new user preferences and consumer behavior, etc., in a regenerative way, hopefully. So that's it from me. And what we're doing now, we have invited a number of panelists to join us. So we have Jan Konietzko, Solange Baskowski, and Daniel Wahl. And I think we're starting with Jan, actually. We're going to ask Jan for your reflections on the presentations, but also then some of the insights from your work, because you've been looking at circular and regenerative business models, and how do you think these how do you think these different design approaches translate into new business models and different organizational practices? And maybe you can also give us some examples that you've identified, how circular and regenerative design not only reduces ecological footprint, but also creates positive impact, the so-called handprint. Over to you.
Yes, thank you so much, Patrick, and pleasure to be here. Thanks for inviting me along. Really interesting presentation and insights from both of you there, and I think it's really great to see how you're organizing a webinar around this topic to give some exposure and also to disseminate more of this knowledge on circular economy, and also then increasingly this idea of regeneration and what it means. So to your question about how circular and regenerative design translate into new business models and organizational practices. So I did my PhD on business models for a circular economy at TU Delft. And in those 4 years, the main thing that I noticed is that actually, if organizations want to move to a circular economy, and then mostly talking about a circular industrial economy, when it's about mostly durable products at the moment, where there's obviously a link with biological materials, if you use wood in buildings instead of stone, for example, or if you use some other sort of or more organic materials. But the main thing that I found is that actually it requires a completely different form of alignment between organizations, what I call sort of an innovation ecosystem. We see this actually now trickling into practice as well, when you have reuse business models, or if you want to recover materials that reach the end of life, you need the alignment and coordination of different players that have not previously worked together. So recycling facilities, manufacturing companies, maybe service providers that provide repair and maintenance services. So that inter-organizational alignment is really key to implementing a circular economy next to the business model itself. For durable products, it's really, the main thing is really about adding more service to the product. So if you, it doesn't have to be all the way down to provide the product as a service, which is sort of the ultimate idea, because that creates an incentive for the company to actually invest into products that are much more durable, that are easy to repair and maintain. So the key is really adding more service to the product, getting the product back, which is currently not happening because when companies sell their products after the first or second use phase, they don't know where the products are. When they provide more of their products as a service or add service to the products, then they can get them back. Then they also understand why they break, how they break, and so on. So this is all for the sort of durable products. The business model, more services added, but also what we call ecosystem alignment. So getting those different organizations that need to be involved in recovering the products, components, and materials and learning from each other. Recycling facilities often know what problems they have in recovering the materials from products at the end of life that actually the manufacturing companies are not yet aware of. So that kind of exchange and coordination is really key. On the circular industrial economy, there are a few traps though. One is a rebound effect. So what we see in the circular industrial economy is that actually in a lot of these reuse business models, it doesn't actually lead to lower levels of consumption or higher levels of resource efficiency necessarily, but to increased consumption. So when something is available more or is easier to access and easier to use, then people will use more of it. So also there's a key caution with the circular economy that actually there is a high danger of what we call rebound effects. Yeah. So when the initial idea of making it better actually leads to a worsening of the environmental impact. Another one is a cutoff point for product replacement. You have washing machines, for example, or refrigerators that are new ones are so energy efficient that actually it makes sense to replace them completely rather than repairing and maintaining them and keeping them going. So also there it's really important to make sure that you understand that cutoff point. When is it better to replace the product because a newer product is just better? And when is it good and feasible to extend the lifetime of products? So that's also a key thing to keep in mind. And so in general for the circular economy, what should, in my view, accompany the whole innovation process and the whole discussion is life cycle assessment to validate assumptions about in how far the circular economy is actually better from an environmental point of view or not. And this is often missing. I see also in practice that companies, they start using recycled materials or they start providing a product as a service, but they have never validated if this is actually better from an environmental point of view. And then the circular economy of biomaterials, or what you mentioned with the biological cycle. I remember a conversation I had when I was still at TU Delft with a PhD student who was half a year into researching the use of biological materials and replacing more artificial materials or durable materials that we have. And that person told me after half a year of doing research, she was still looking for the problem that bio-based materials are supposed to solve. Meaning that in a lot of cases, actually, it probably doesn't make a lot of sense to use biological materials to try and replace some materials that are actually very high performing and can be recycled and reused for a really long time. And also because bio-based materials and all kinds of products creates additional stress on land use, and land is the one thing that we don't have available anymore globally. Now for regeneration, this was just a curiosity 1.5 years ago, together with Nancy Bocken, who's Professor of Sustainable Business in Maastricht, and Ankita Das from India, a PhD student in our research group, because the Ellen MacArthur Foundation came out and said, the circular economy is regenerative by design. So we already started wondering, what does that actually mean? And then we started researching that topic. We organized a number of focus groups to better understand, what is regeneration? And here again, the same thing with the circular economy. We are looking at an umbrella construct. So now, as soon as you take an analogy from nature, which circularity is, or regeneration is actually a biological concept. If you take that and put that into a social, economic, and cultural context, it becomes an umbrella construct that is open to a lot of different interpretations and meanings. And then this whole process starts of different organizations and universities trying to figure out what does it mean. What we came out with is it's really key to go by industry. There are some key industries where regeneration matters. That's food and agriculture, especially meat and dairy, because 85% of all agricultural land is dedicated to meat and dairy production and is highly polluting and also highly ethically questionable about how the animals are being treated in the process. Construction and infrastructure is a huge sector where regeneration matters because it requires a lot of materials and it's also very land use intensive. Also, what we found is that regeneration goes beyond the environment. Circularity is a lot about environmental impacts. You know, it's a lot about resource efficiency, material productivity. This is at least how it's being used in practice. Regeneration goes a lot deeper into questioning, in general, our relationship with nature, our relationship with people, and with animals. And it also goes deeper in questioning the purpose of an organization. It requires new forms of leadership that actually question the very essence of capitalism, which is about maximizing shareholder profits to reusing profits and reinvesting them into nature and into communities. And there we have, for example, Patagonia as a famous example where Yves Chouinard said at the end of his life, they were trying to find a legal structure to be able to invest the profits that they make into natural capital. And now funnily enough, you see the CEO of Patagonia being in Albania, the last wild river in Europe, and investing $2 million into conserving that river. Yeah, this is because they said, okay, we want to reinvest profits into nature. So this is I think it's very ambitious to achieve this at scale. It's a direct criticism of the way capitalism works at the moment, which is profit into private pockets. The idea of regenerative economics is profits back into nature and profits back into communities. It also demands honest assessments of the true costs of products and services. Yeah, it doesn't only mean that the social cost of car is included in the price. There are studies that show that the social costs of cars are about 4,000 euro per car per year. It's also about making those products cheaper that provide benefits. For example, an apple, a conventionally grown apple at the moment in the supermarket is too expensive because it doesn't include the health benefits that it provides to people. So ultimately, it's a cultural and political question, regenerative development. And it's about what you already mentioned, maximizing the handprint and minimizing the footprint of products. And I think this is a really nice, very pragmatic way of looking at it. You mentioned the solar PV example. Yeah, if you take a solar panel, it has an environmental footprint. So it's all about what materials are used in the PV panel, how the panel is produced, which at the moment is still largely in China using coal-based power plants. So that's the environmental footprint of the solar PV panel. The handprint is what does that solar PV panel change in the market? It's replacing mostly coal-based electricity production. And then you see a 95% reduction in environmental impacts. And that's the handprint. So I think regeneration, it's very nice and pragmatic to frame it in terms of environmental footprint of the product and environmental handprint of the product in terms of what difference does it make in the market. And then back to your question, how can that be assessed? To be honest, I think we don't have to reinvent the wheel. LCA for environmental impacts is here, and it makes sense to also apply that to the handprint and the impact in the market. What you do need to do is really investigate what changes as a result of putting a product on the market.
Right.
Yes.
Okay.
Thank you so much.
Thanks, Jan. Yeah. You expanded that out quite a bit. Regenerative economics or even regenerative politics could be included, which is great. Let's bring it back a little bit to the specific products, and I think we go to Solange now, and you're working with Philips specifically on circular economy. Could you tell us a little bit more about how you're using circular or regenerative design principles and the evolving standards that Martin talked about? How are these being taken up in the product design? And I understand, so circular design is already something that's being practiced, but how do you use the regenerative design term? And then maybe, because you're also involved, what's your perspective on the upcoming standardization processes and the policy developments? So the eco design update, for example, what can we expect from that?
Okay, thank you, Patrick, and Martin also to invite me here. So it's great to be here and to share a little bit on what we do and the things we are developing in terms of standards with you. And I saw there's quite a number of participants. We have above 100 participants, so I hope people are enjoying this afternoon. So a little bit what we in Philips do in terms of standardization, and how do we take up the standardization. So if you think that, in fact, we have been developing the circular design, we called it in the beginning circular ready design of products for, I think it's at least 10 years, and deploying it throughout many countries where we are having our development centers. And that process is a very demanding process. So when we thought, we realized that JTC10, the joint TC10 and Sensenelec developed many standards around material efficiency, as Martin has shown to you. It was back already in 2019 and 20, but there was no standard linking design. So we have a way to assess how durable, how repairable, how remanufacturable a product is, but how to make it better, how to improve all that thing. It was not there. We didn't have those standards. And then it was an idea from Philips to really start developing this standard. And of course, we used the way we have been implementing it within Philips as a start point for developing this standard. Of course, we didn't stop, so we're developing that all further. Like the standards, it develops further it's a consensus-based approach, where there are many ideas from many countries and many members that you need to take into account. So you have both evolving in parallel. So in Philips, I see things happening now. Like, for example, they just finished development of a tool to assess how recyclable a product is. It's a very difficult thing to say. You have many, because simple products like our carpets, or I don't know, polyester textile, maybe it's easy to identify, but an electrical electronic product, it is very different types of materials that are being combined, and at the end of the day, how much of it is repairable? So can you give a number to it? And this is one thing that we just have been able to develop in Philips, to help our process of making our products more circular. So we have a number of targets, and that's one of the thing. And I think this will be needed as we go forward. Besides this design standard that we are developing in Sensenelec, we will have also need more tools and more ways to assess. I mean, you're discussing about life cycle assessment. We need to apply more life cycle assessment, indeed, to understand and to be able to make trade-offs and to be able to make choices, because at the end of the day, when you do your design, you have many different options and you need to choose which one is better. It's not only cost, but it's also benefits and the environmental and also circularity benefits. So going back a little bit into your presentation, I think Martin has presented that a way we are doing circularity today is making small improvements in the durability, in the repairability, into the refurbishing aspects, and so. But one thing that we see as well is that the big changes are in when you're able to do these breakthrough innovations, technology shifts, and that's where you have the biggest accomplishment. So one thing that we did, and just to give an example of what Philips did, is we have this MRI, so the equipment, the huge machine tones of material in there. That's magnetic resonance imaging equipment. I think most of you are familiar with that from hospitals and so. And that equipment makes use of helium in order to manage the temperature, to cool it down. Normal traditional equipment use around 1,500 liters of helium in a continuous basis. So and it's a not completely sealed system. So you lose it all the time. You need to replenish it. So we have been able to develop a technology where we went down to 7 liters, from 1500 to 7 liters in a fully sealed system where we don't have losses anymore. And I think those are, so the breakthrough innovations are the ones that are really going to bring us in the big steps. But of course, we also need to do the small steps. And where you see is that quite often companies, when they start developing and they start implementing circular economy at their organizations, they don't understand what circular economy is. Circular economy is just too complex. And in general, they think circular economy equals recycling. And of course, we need to do recycling, but the recycling is the worst of the good. So it's something that we need to do only when all the other strategies to reuse, repair, continuously maintain the products, to refurbish, and then at end of life to repurpose it, to remanufacture it, or only then you go into going back into the original materials and recycle it. About the regenerative aspects that you asked me, we are not using the term at Philips yet, but we are definitely looking into that. One thing that we are doing now is into operations. For example, our buildings, and buildings is one of the most popular, like agriculture, as you said. We are implementing in the buildings, we are looking, for example, into the possibility to have walls to absorb CO2, for example, helping the overall climate change problems we have around. Bio-based is definitely being very much pushed from the government. You see the European Commission coming with legislation around bio-based. Bio-based is tricky because on one hand, yeah, fantastic. It's renewable. It's regenerative by design, by essence. But on the other hand, you see that people tend to misuse or not to know enough to use it. So the moment you mix bio-based materials with your oil-based materials, your polymers, you're really, you're going to the wrong direction. The other thing is that if you use them even separate, but you don't bring back into the soil, then you're not closing the cycles. So we are certainly looking into those aspects, but with a completely different eyes than this was done in the past. Really looking into the cycles, are we able to close the cycle and bring those materials back into the into nature so that they have the possibility to be regenerated and so on. So I cannot give you any example, a concrete example here, because it's all beginning. We do have some concrete pilots going on, but they are still only internal thing. And then the last one about the new legislation. ESPR. ESPR is becoming really, like probably you have heard in the past, REACH. We have a kind of dinosaur of legislation after we had ROS. Well, ESPR will be a little bit of dinosaur legislation because of its complexity. You shown, I think it was your last slide where you shown a number of, I think, 10, 12 groups of products, sectors that will be first affected, but those are just the priority for now. But actually the SPR will apply to almost anything we have around, except a few things around food and medicinal products. So it's a huge legislation. It encompasses, it's called eco-design, but in practice, it has so many other aspects in it that it goes far beyond the eco-design. One of the things that they have in there is, that, for example, digital product passport. And digital product passport is all about data, availability of data, traceability, and making available data. And I think if we look into the whole future where we are going into as organizations, data availability and traceability will be the most demanding for organizations, because we need to know in details all the circularity aspects of our products, but also the material, what they are made of. And the more complex the product, the more information you need to gather from. So from standardization perspective, we are now developing, we have a standardization request around digital product passports that is looking mostly into the framework, so the IT framework, how to make all that data available. So in a couple of years from now, I think from not next year, but beginning of the year after, we are going to start looking into what is the data that needs to be available per product sector. And of course, some product sectors will have higher priority than others. And it's very typical because we as electrical electronic products, we are dealing with data exchange because of the ROS, restriction of hazardous substances legislation, already since 2000. So we have been dealing with data for very long, but for some sectors, this will be the very first time. So it's going to be really very challenging for all the sectors to cope with all the new requirements that will appear and as part of the SPR with the individual product, all the act implementing acts. So yeah, I don't know if this is what you.
Yeah, thank you. No, this is extremely insightful. Thanks for explaining this. And then, I mean, the last point, it'd be very new for many sectors to have that level of data requirement. But I guess then the challenge is then also because it's about the whole supply chain as well. So it will require this very close cooperation with also a lot of the companies outside the European Union that supply into those value chains.
Absolutely, yeah. So we will need to have, and standardization is really fundamental to get all that information. So we do have already a number of standards that have been developed for the electronic sectors, but that are now being upgraded or broadened into the all ISO and IEC, so all types of products. One of them is the material declaration about products, where we also include the information of circularity, like recycled content, reused content. The recycled content is that pre-consumer, is that post-consumer. So all the thing that's going to be part of legislation in the future, we need to be able to gather that data. And standards are really fundamental to help organizations. So the complexity is making, so you know, how to eat an elephant, make it in small pieces. I think that's what the standards do. They help to break things in small pieces and to make them easy for people to understand. So I can guarantee you there will be plenty of opportunity for us to standardize in the future.
Okay, yeah, I like this the example of the elephant, because we also know the other kind of metaphor that's used, right? If the blind man who are only looking at parts of the elephant and then don't understand the full picture.
That don't have the full picture, absolutely.
Exactly. So yeah, we need to have the standards, but also be able to fit it all back together to see the whole.
The whole thing, yeah.
I guess this is where Daniel can come in now, because
maybe Patrick, just if I ask someone just a quick question, there just seems to be an avalanche of policy developments around product circularity, an avalanche around different standardization with circularity prefix across different sectors. I mean, you as a professional right in the center of this, how are you able to manage all of this?
It's becoming very difficult, Martin. Yeah. It's becoming slowly a mission impossible. So what you see in particular circular economy, what we see is that there are so many activities happening in parallel that you can even not follow them all anymore. Yeah, it's just becoming really too much. I don't know where we are going to end up, but in some moment we are going to need to find a way to deal with all this, because the way it's going up, it's not going to be possible for people to cope with it.
Yeah,
I see that it's really an issue. Yeah.
I mean, that's an issue that I also face, in my role, as the sort of chair of the circular economy group within BSI, trying to track everything that's going on and get the right type of input from different stakeholders, particularly from industry, who have got limited time to focus. It's becoming a huge challenge just to keep on top of it, but anyway, I'll pass back to Patrick.
Yeah, and I'll pass over to Daniel, because you've been engaged in this space also for a while, and you've published a book about regenerative cultures, and you've given us a good reading list here already in the chat. I see lots of links to your work. So how do we bring these things together?
Well, first of all, just double checking, how long do we have? Because we're seeming like we're already at 10 past.
Yes. It's fine. Maybe you can talk for 5 to 10 minutes, and then we could go over to the participants. Like some people have raised their hands already, so we'll also have time for you to comment.
Well, if I'm honest, I'm having a bit of a reality shock, because I could start with the blind man and the elephant and feel like there are just so many perspectives that have not been at all included in the conversation so far, that I feel like we need to sort of briefly zoom out and say, what are we actually facing? In the chat, there are lots of different aspects of it. Put a link to Nate Hagen's work, who started the Institute for the Study of Energy in Our Future. And he did his PhD on the global energy system. And it's really worth that. I also linked the academic paper he published on that, just for those who need to be within the academic publication citation game. To some extent, I feel like part of the misrepresentation of regenerative design comes from that I've heard, that if you do an academic paper research, you don't actually get the core of regenerative design thinking, because that community is outside the academic discourse. But just to put a few basic things straight, we're currently running a 70 trillion watt civilization, which means 17 billion 100 light bulb watts are being used in terms of energy any second. That is fundamentally impossible to sustain. 85% of that comes from fossil carbon or hydrocarbons. And we now know that we cannot keep using them in that way. So we're faced with creating a material culture in the future that services 8-9 billion people with, if we're lucky and we develop renewables a little bit further, let's say a quarter of the energy we're using right now. And also, we've increased the material throughput on planet Earth used by humanity 1,000-fold in the last 100 years. And it won't do to just try to make it circular. And what I heard from Martin and Solange towards the end, like it's getting ever more complex. How do we cope with that complexity? And we're just going to generate even more data, and then it becomes even more complex. Well, that kind of direction of travel leads you lovely into the next level of, oh, we can't make the decision, AI has to make it for us. But the reality is that we can handle complexity either through ever more abstraction and crunching data, or we can handle complexity by embracing it, but then we need context. And this brings me to the circular economy, because one thing that people simply seem to forget, even in that arc that Martin showed, they went from Victor Papanek to cradle. There's a very important middle piece there that is actually where this thinking was first brought into industry and academia, and that's industrial ecology. So in many ways, industrial ecology is the essence of this work. And then Michael Braungart and Bill McDonough reframed it with Cradle to Cradle. And yeah, that was great work in terms of bringing that kind of thinking to the built environment, and through Michael also somewhat to industry. And then Ellen MacArthur picked that up, rebranded it yet again, and sold it to the world very effectively, so that now every industry is talking about circular economy. But at every one of those reframes, we threw out a little bit of the baby with the bathwater and didn't pay attention to certain strong points in that. And the baby we threw out when we ignored industrial ecology is that the core idea that said, what's going to make this really reduce our human footprint on planet Earth is to re-localize and re-regionalize the cycles. The smaller the cycles, the more effective the system in terms of energy and material use. And then Bill McDonald kind of ignored that a bit because it was more convenient for the build industry to have a wider area of drawing materials to build buildings. But they still highlighted that in terms of cyclability, increasing the biomaterials cycle of the Ellen MacArthur diagram and decreasing the industrial materials cycle was a good idea. And then the next reframe, that went out of the window, and we blew the thinking and research on circular economy up to continental and even global scales, moving materials that were waste products of one part of the globe to another part of the globe to make them raw materials. And that's simply, when we look at the kind of energy reduction we now need, a ridiculous amount of energy waste that we need to avoid. Behind me is a map of the world's river systems. The bioregional or re-regionalization approach to meeting human needs in the future within the ecosystem or the ecological social system within which they're embedded uses watersheds usually as an initial approximation for the scale at which we should build regional circular biomaterials economies. Jan quoted a colleague from Delft who, after half a year of PhD research, couldn't find a problem that biomaterials should solve. Well, in this chat, I put both the American Chemical Society and the Royal Chemical Society in the UK's reports on. One of them is called Endangered Elements, the other one called Elements in Danger. But they're all looking at the material depletion curves of the periodic table. A friend of mine from the International Futures Forum, Ian Page, has dedicated his last 10 years of retirement to doing this research. And his conclusion is that ultimately, if we want to build circular economies that aren't just a stopgap for another 50 years or 100 years or maybe 150 years, if we had the energy, which we don't, we need to look at what kind of materials does nature cycle freely at low energy costs. And that's carbon, hydrogen, oxygen, and nitrogen. And you can add, like if you take the Biomimicry Institute's approach to also saying exactly the same thing, they add phosphorus and sulfur because we need those for the biomaterial cycle to function. So really, coming back to the regenerative misrepresentation, Kara Sanford has a good kind of litmus test for if something is regenerative. If it's an abstracted standardization process, a certification process, something that is supposed to serve everywhere, it's not regenerative. Regenerative has to be sourced out of the biocultural uniqueness of place, out of the local ecosystem and the local culture. And regenerative design solutions don't foreground the product, the outcome, the deliverable, the building, whatever you in our objectified design thinking, think is the object of design. They still implement solutions, but they implement the solutions or build the product or the building as a means of building capacity of people in place to really understand the material and energy flows behind that building, be capable of relocalizing and re-regionalizing them as much as possible. And of course, it's a nuance, and this is why I'm a little bit frustrated hearing the conversation so far, because I think one of the critical elements where academia could do such important research right now, before we have the cascading collapses of the current economic and business system hitting us to the point that we're forced to regionalize. We should now look at if in the future, like the hard science tells us we need to, unless we believe in cold fusion and some kind of technology riding over the hill to save us, if we're looking at current capabilities with regard to energy and materials, we need to reduce our materials consumption to at least a quarter and our energy consumption at least at to the same reduction. That means if we focus on a bioregion and we try to enable a new opportunity for innovation of small companies, for building vibrant local economies, for reconnecting people to place and understanding of place, because now they need to build their businesses based on the biophysical reality of the places, the watersheds they inhabit, then we actually generate a much more resilient economic system, because we generate lots of regional economies with their regional circular economies that are coordinated at national and global scales in the way that a subsidiary system functions, which means that the global or national systems are subsidiary to enabling that regional circular economy. And that's where the both and comes in, because it can't be a radical only biomaterials, nor can it be a radical only local and regional production. But the research should really be, to my mind, instead of creating another standardization process and another data collection process, to actually look at what are the materials we do need to mine for the next 100 years, and how can we start having the conversation how to prioritize the energy budget that we have as humanity and the material budget we have as humanity to enable regional populations everywhere to have a blend of back to a much more regionalized biomaterials and hands-on, like more eyes to acre, more people back in primary production future that is fundamentally be made much more comfortable than the agricultural system of the past by enabling technologies like the ones we're using right now to talk to each other. But this pipe dream of ubiquitous technology everywhere and this system that we're running right now to continue is a utopia. Like very often when I talk about this re-regionalization process, somebody says, well, it kind of makes sense, but isn't it all a bit utopian to think we could do that? We have to anchor that this we live in, this current system is the utopia. And in a similar way, we have to stop talking about regeneration like, well, we're thinking about it, but we're not quite officially using that term, as if it's the new label that we, after smart, circular, and regenerative or sustainable, now we slap on regenerative. We have to, if we really want to take what regenerative is all about seriously, then we have to understand that it's the essence of life's capacity to self-organize. It has been there from the beginning. It's at the core of what Janine Benyus talks about when she says life creates conditions conducive to life. It's happening in all our bodies right now, in every cell, in every organ. We are constantly regenerating. And we as human beings, for 290,000 years of the Homo genus, have been bioregional, watershed-based individual species, a bioregional species that understood itself as an expression of that place. All indigenous cultures have a relationship to place, not of ownership, but at very best as custodianship or guardianship, and they understand that they are literally living expressions of that piece of nature that they're living in. So we are nature, we're not separate from it, and culture is not beyond it, and technology is all embedded in it. It's just desperately maladaptive the way we're using it right now. So even the nuclear bomb is part of nature, it's not outside of it. Otherwise, we will never understand what nature or life as a planetary process really is. And that's the other bit, that life is fundamentally, like you can look at life either through the lens of individuals and individual species. And when you foreground that, then you see a lot of competition. But if you look at life as a planetary process, that is a bit more like a mushroom mycelium, in which every species and every individual is a temporary fruit body of a living entity that is Gaia or the Earth system biosphere, then you can begin to understand that all of it is a self-regulating syntropic process that, with regard to the energy balance from outer space and on this planet, is actually syntropic. It runs against the march of entropy for a period of a few million or even billion years. So the second law of thermodynamics on a universal scale still holds, but the time scale of biology and human or life's evolution is at a different rate at the time scale of physics. So I think we really need to, like, I don't want to offend anybody who delivered, because I know these are caring individuals who want to make a difference, who are intelligent and resourced, but we need to get real about what kind of contribution can we make now to look at re-regionalizing production and consumption, and what materials do need to still be mined and circulated in the material cycle in order to enable that future. I also want to highlight that that's one of the things I didn't put in the chat, but you can, for anybody who doesn't know this, if you look at the chat and the 3 dots at the bottom, you can download the whole chat and look at these links later. But there's a TED talk, if you put Olivia Lazard, I'll put it in a second, the blind spot of the green energy transition, or the Green New Deal. She works with the Carnegie Foundation in Europe, and they looked into where we would actually need to do the mining in order to make this technological jump into a kind of electric car, renewables future. And about half of the minerals that we would need for it are under the biodiversity hotspots of the planet. Surprise, surprise, indigenous owned territories, where the indigenous people have actually been the custodians of that biodiversity. Even and more, what we now find out through science is that when humanity is an expression of place, we have regenerative capacity. We increase the biodiversity and the bioproductivity of systems. Lila June just published a PhD at the University of Alaska, where she looks at these systems.
Daniel, sorry to interrupt, but Jan, we just want to have
there was a lot of babble before, and I had 10 minutes, so it's okay to interrupt me. But
no, yeah, I'm sorry. But really good point. I mean, also good criticism that you're making, highlighting also the need for regionalization to be able to regenerate. And I mean, the last point that you make, if we drive this energy transition, we undermine regenerative capacity, all of that. So I fully agree with your point about we need to bring in the sufficiency debate into this.
That's not my point. My point is we need to bring a place-sourced local lens to all of it. We need to do this work on the local and the bioregional scale, and in that process not become insular and only our region, but coordinate between bioregions and enable bioregions to come back to place. That's my point.
Great.
So I think that just a quick comment, Patrick, is I think that sort of hyper-regional element in the technical system is being exemplified now by the nearly 3,000 repair cafes, for example, that's emerging, which are hyper-local, hyper-community. But I mean, I think your point is well made, Daniel, about that context. But I see we've got one hand up. Loris, and I think I will try and allow Loris to make a comment. Do you want to make a comment, Loris? We're not having these challenges with the technology today, because I thought I'd allowed Loris to talk. Are you able to say something, Loris?
I'm muted.
Yeah. I'm giving her permission, but the system is not allowing her. So I think...
And you can also put questions in the chat. We can just read them out.
Again, there's some sort of some technical issues there, but I think we're drawing to the end, perhaps, Patrick, and I don't know if you want to summarize the key points from your point of view, just for time.
Yeah, sure. I mean, the key point from my perspective. So yeah, starting with Daniel again. So that's so I think the question about utopian is quite relevant. Yeah, are we living in a utopia now? Yes, we probably are. And is the AI future a utopia? I probably agree as well. And it's yeah, I think the question, the point that you also made about are we going to be forced, or can we have a managed transition towards a regenerative system? I think that's a key. But on the other hand, we also we might have this utopian view on things, but we're also living in a reality of a highly interconnected world where global trade and interdependency between countries is also a reality. So how do we shift that system? And that's, for example, where big companies like Philips have a key role to play as well. How does that transformation will take place in a managed way? Because we can, yeah, and then the question is, does that circularity complexity will be too high to manage?
I'll be rude briefly because I really had a lot less talking time and I had to listen to quite a lot of stuff. Two things that people should maybe also put in to their mental toolbox is the notion of energy return on energy investment and material return on energy invested. And to understand that even if we look at the current availability of certain ores, and they're normally stated as total geological reserves, but the access to these ores depends on an economic level and an energetic limit to accessing them. Because there's a point where we simply cannot, like, either the material is so diffuse in the substrate that it takes huge amounts of energy to get it out, or and this energy then in this future that we're talking about is needed for other processes. So, and talking about the MRI scan that Solange was mentioning, those are precisely the kind of technologies that we would love to maintain at a bioregional scale, making them available, but not in a competitive economic system where there's 20 of them in one region that are trying to make money out of the investment that they built one machine. But it needs to actually be the entire fundamental economic system that is a win-lose game also needs to be addressed in all of this. And
Daniel, can I ask you something? Yeah. Because you were talking about the regionalization of resources and use resources on the basis of availability and made them available to the different regions on a more fair way. That's more or less what I got it from it. Maybe I misunderstood, but how do you do that without involving all the governments? And how do you align all the governments? Because this is not something you and I can do. Yeah, and not even Philips. This is really something so fundamental that it's very much comparable with the whole climate change problem that we have on a global scale, and there is no alignment on that. So how do we achieve that?
Buckminster Fuller, one of the great pioneers in kind of systems design, said, don't try to fight the existing system, build an alternative system that makes the existing system obsolete. So for a company like Philips, and I'm involved with a number of companies that are looking into decentralized manufacturing, and looking into what are the technology platforms that we would need to create. For example, a company like a detergent company coming from Belgium, I won't name the name, looking at, which is recently merged with an American company, I won't name the name anyway, but we looked a while ago into this local manufacturing approach and how we could use something like the island I live on, Mallorca, to play around with this biomaterial circular economy and looked at local waste streams in agriculture and in forestry and organic urban waste and analyzed them in a lab to see what kind of chemicals one could extract from these streams and how they then could form the basis for detergents and so on and so forth. And at that point, because you always have to have a hook into the current economic and material culture, to basically create detergents for the beds of the hotel industry and floor cleaners and hand soaps and all of that. And it becomes very complex when you actually start doing that. And you realize that you can't do it just as one company. You have to build a whole local ecosystem. And you can't even, like, that's where the regulator then comes in, because you need to really be biomimetic in the use of all these available biomaterials in a region and do a cascading of the material use. Because if somebody comes along and says, oh, like biomass for burning is green energy and give me your agricultural resources, I'll burn them and it's green, then you miss the opportunity to put it into a biodigester and actually create key chemical resources, just as one example. So it's a complex redesign of industrial system. That's why I mentioned industrial ecology, because their focus was to create co-located industries that are engaged in exactly that kind of building, literally an industrial ecosystem, where through current solar income and energy available in that place, you try to meet various human needs by linking these industries together.
And ask you another question, Daniel, as well. But is, you know, industrial ecology as a concept, the first books were published in the early 1990s. Why hasn't really industrial ecology been picked up by industry? Still really there in academia. Yes, we've had industrial symbiosis models, you know, waste equals food, blah, 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 emerged on a process level. But why has industrial ecology not really been picked up and brought in to the, you know, brought into industry and et cetera, et cetera?
Up until recently, now that we have a debate that industry can't avoid anymore with regard to climate change and biodiversity, and we've had a shock to the system through COVID that made us understand how quickly business as usual can be radically different the next moment, which has enabled a new conversation that was previously not possible because people were just so believing that things will be as they are, and anybody who says otherwise is just painting a black future, and was marginalized very quickly. And then shortly after, we had the ship stuck in the Suez Canal, and we realized what a massive economic like chain reaction just one little incident can have if you have highly globalized supply chains. And then after that, we had suddenly the old specter of the power block politics of the last century come back with a vengeance with the invasion of Ukraine. And now we're beginning to realize, oh, all these trading partners, peace through trade, might not actually be trading partners so soon. And the technology exchange we've done into China has enabled China to rise to a way that we might actually possibly also not like when you're thinking in terms of power blocks. Not that I'm thinking like that, but the reality is there's clear signals of what happens in this process of globalization. In the 90s, when the industrial ecology conversation was happening, it simply could not be heard because everybody was globalizing. Like the brilliant small and medium-sized enterprise that were the backbone of the German economy, that produced one type of pump, but that was the best one in the world, also were forced into producing more and bigger and in China. And that whole process has created an incredibly brittle and interdependent system. And it's only when we wake up to the point, and that was my initial frustration, I really don't want to offend anybody here, we need to start from the point that the system we are in is in a phase of cascading collapses, and they're clearly visible all around us. So any assumption of designing with that system is like assuming building blocks that we might not have in 20 years' time. So only by, like, even the economic dogma, like the word redundancy, if I say redundancy, it probably brings up a negative image to most people at the moment. But redundancy is a core element of resilience. If you don't have, like, it's about decentralization and repeating vital functions. So in case one of them gets disrupted, you have another place where that function can be taken. That's why you've got 2 eyes and 2 ears and 2 kidneys. That's redundancy.
Okay,
and
well, I think it's been a very furtive conversation. I think we've stretched for many dimensions, and there's a lot of food for thought there, and I think maybe I'll pass it back to Patrick just to close off the session.
Okay, yeah, thanks all for the discussion. Yeah, I'm sorry we weren't able to answer some of the questions in the chat, but so I guess, I mean, what we do, we'll follow up. So there's a question whether we can share what's in the chat, the links that Daniel put in there, and we'll do that. And yeah, please. So we'll there's a recording of this. I think this probably becomes available on the website of the World Circular Economy Forum. I think because we're co-hosting also with them, and I think what we do is we provide a short summary of the discussion as well, also to share.
I think also, if the conversations sparked any thinking or any specific areas to probe further, particularly, what this means for product, services, and new business models, please be back in contact with Patrick or myself, because we're keen to sort of evolve things forward in this complex landscape.